In Module 4, we focused on systems approach to quality and productivity and how to establish quality and productivity as a business strategy. In Module 5, we focus on understanding variation. The basis of this module is two quotations, one by Dr. Deming, "Understanding variation is the key to success in quality and business," and one by Dr. Nelson, "The central problem of management in all its aspects, including planning, procurement, manufacturing, research, sales, personnel, accounting, and law, is to understand better the meaning of variation and to extract information contained in variation." If we consider the outcome or the output of a process, that output is subject to or reflects many factors affecting variation. So this is called a fishbone diagram, a cause and effect diagram, and sometimes named after its inventor, Dr. Ishikawa diagram. In this cause and effect relationship, we look at some of the causes that produces this effect. So in a general way, we want to look at what are some of the factors that affect the variability in process. These are some general primary factors as people, material, machines, methods, and environment. For example, under people, training and education, the quality of supervision are very important and have an effect on the variability of the process. Under materials, working with quality suppliers, consistency of the incoming material, our purchasing policies all have major impacts on the output of the process or the variability in the process. Machines, the maintenance of the machine, the training on new machines are very important. However, one point that is important to point out here is that often we rely heavily on automation as a panacea, as a cure-all for reducing variation in our processes. Although automation is a factor, and we have to consider that, but automation alone does not remove the causes of variability. If a process is subject to considerable variability and producing defectives, we have to really look at the causes of that before we proceed with automation. Methods. Are we involved in continuous improvement, or are we just allow obsolescence to settle and move in, so the idea that we've always done it this way? Do we have standards and standard operating procedures? These are all contributing factors. If we are involved in continuous improvement, perhaps over time we reduce variability in the process. If we have standards or standard operating procedures, then also that reduces variability in our processes. The environment of the process or the organization is very important. Do we work in an environment of cooperation or competition? Competition often leads to a win-lose relationship, and cooperation leads to win-win relationship. Is there fear in the environment? As one of Dr. Deming's 14 points is to drive out fear in the workplace. Fear is a factor that we have to seriously examine. Fear in the workplace. Often fear destroys communication and leads to operators and workers not reporting problems. Is our workplace healthy and safe to work? That's also a factor involved in understanding variation in a process. So this is generally some ideas, some factors that can contribute to the variability in a process. We can customize these or adapt that to any processes. Originally, these were called manpower, materials, methods, and and machines and methods, or 4 M's of a process. However, this is a generalization of that, and also we can adapt this, change these primary factors, secondary factors to examine a particular process relating to a particular workplace. So to better understand, this is a monthly report. This is figure 3.1 from Understanding Variation, Dr. Wheeler's book. The idea is, how do you make sense of reports, such reports? And perhaps in this case, in-process inventory is something that has to be examined. So, as Dr. Myron Tribus says, managing a company by means of the monthly report is like trying to drive a car by watching the yellow line in the rear view mirror. Essentially, it tells you where you have been, but it won't tell you where you're going. So, perhaps the in-process inventory for Department 17 is an area that is being examined. So some of the methods of data analysis, perhaps we compare our current in-process inventory to in July of this year compared to July of last year, or perhaps July of 2 years ago, or perhaps we compare it to last month. So essentially that tells us we were 12% above last July, 27% above July year before that, and 47% above June this year. So obviously there is variability. All the numbers are not the same. Some numbers are higher and some are lower. So the message is, explain the change, do something. In other words, explain this movement of these points on this chart. Explain why there is so much difference from here to that point, from here to that point, or comparison of this month to July of this year to June of this year. So explain this 40% difference. So if you look at the comparison of the points, if we look at those values we just referred to on a chart, obviously there are some movements of points up and down, and essentially some variability in these in-process inventory. So overall, if you look at the entire data set, we see here. Similarly, we look at the entire in-process inventory for Department 17. There are some variability in this process. Now, if we plot those points over time, a run chart, time series, you can see the 3 points that were being compared essentially are pretty much a part of a system of variability, and it has to be looked at in that context. And later on, we'll look at Shewhart quality control charts. This is called an IMR, or individual and moving range control charts. And as you can see, all the data points are within upper and lower control limits of the process, and all we see is random variation or noise in the process. So what we'll examine in the next few lectures is that how to extract information in variability, in variation, and how to use that, how to characterize the variation, and how to use that for decision making into the future. The next couple of slides simply refer to collecting good data and Shewhart's rules regarding data analysis.